Have you ever stopped to think about how a tiny device in your pocket can capture entire memories, emotions, and even art? Whether it's a smartphone, DSLR, or a cinema-grade camera, these devices are all built on one fascinating principle: capturing light. And today on Knowledge Hub, we're diving into how cameras actually work. At its core, a camera is nothing more than a box that controls how light enters, and for how long. Let's start with the basics. Light from the world around you reflects off objects and travels in straight lines. When this light enters the camera through a lens, it gets focused onto a flat surface, traditionally film, but now almost always a digital sensor. That lens is crucial. It bends, or refracts, incoming light rays so they converge at a single sharp point. The lens's curvature, glass quality, and focal length all determine how zoomed in or wide the image is, and how much light hits the sensor. Now comes the shutter. This is a tiny curtain inside the camera that controls the duration of light exposure. When you press the shutter button, it opens, just for a fraction of a second, and lets light flood in. Too little light, and your image is dark. Too much, and it's blown out. This is what photographers call exposure, and it's a delicate balance between shutter speed, aperture, and ISO. Let's break that down. Shutter speed is how long the sensor is exposed to light. Fast shutter speeds freeze motion. Think sports shots. Slower ones let in more light but can create motion blur. Then there's the aperture, an adjustable hole in the lens that widens or narrows to control how much light gets through. A wider aperture lets in more light and creates that dreamy background blur, also known as bokeh. A smaller aperture brings more of the image into sharp focus. Finally, ISO determines how sensitive the sensor is to light. Crank it up, and you can shoot in the dark. But go too high, and your image gets grainy. In digital cameras, all this light information hits the image sensor, usually a CCD or CMOS chip, made up of millions of tiny light-sensitive cells called photosites. Each one captures light intensity and color, converting it into electrical signals. These signals are then digitized, processed, and stored as the images you see. Smartphones take this even further, using computational photography. They combine multiple shots, apply AI-based corrections, enhance shadows, sharpen edges, and balance colors, all in milliseconds. But at the heart of it, whether it's a vintage film camera or the phone in your pocket, it's all about capturing light, shaping it, measuring it, and freezing it in time. So next time you snap a photo, remember, you're not just clicking a button. You're opening a tiny portal that records the world using physics, optics, and a little bit of magic. Thanks for watching Knowledge Hub. Don't forget to like, subscribe, and hit the bell so you never miss a deep dive into the tech all around us. And as always, stay curious.